So we're looking at the graph here on example 3 of the answer, and we can see that since the function had one real zero at -1, you can see it crosses the x-axis at -1. And the other two zeros are imaginary numbers, so the function's not actually going to cross the x-axis whenever there's an imaginary zero. So here's what our graph looks like. All right, let's check out a check your progress problem for this example. Go ahead and pause the video as long as you need and find the zeros for this function. When you have your answer, go on to the next slide. All right, for this problem, the answer is choice A. You have a real zero at 1, and you have imaginary zeros. Oh, they're not imaginary, actually. They're at 1 minus root 5 and 1 plus root 5. Notice there's no I in here. So these are all real answers. All right, here's another key concept. It's called the complex conjugates theorem. It says let A and B be real numbers and B cannot be 0. If A plus BI is a 0 of a polynomial function, then A minus BI is also a 0 of the function. So if you see one complex number that's a 0, the conjugate of it also is another 0 of a function. Okay, example 4, we're going to use zeros to write a polynomial function. And it says we need to write a polynomial function of the least possible degree with integral coefficients. And the zeros of this polynomial are going to be 4 and 4 minus I. Okay, so we know from the complex conjugates theorem that if we have 4 minus I as a 0, that we're also going to have 4 plus I as a 0. So that means that we're going to have 3 total zeros, and we can write our factors in the form of x minus the 0. So we're going to write out x minus 4 times x minus 4 minus I times x minus 4 plus I, and then we're going to have to multiply all that out and see what we end up as our final polynomial. So usually the easiest thing to do is to work with their two terms over here. If they have i's, work with those terms first. They reorganized and regrouped these two things so that they would both have factors of x minus 4 in them. When you have something plus a number and the same thing minus the same number, that's going to be your difference of squares. So they use the difference of squares formula to simplify these two pieces right here into this expression. And when we multiply that out, we get the following right here. And if we simplify that, we get x squared minus 8x plus 17. And then we're going to multiply everything in here times x minus 4. When we do that, we get all of these terms. We combine our like terms and simplify, and we end up with x cubed minus 12x squared plus 49x minus 68 as our final answer. All right, check your progress problem. You're going to look for a polynomial, and some of the zeros of this polynomial are 2 and 1 plus I. So pause the video as long as you need. When you have your answer, go on to the next slide. Okay, our answer for this one is choice C, x cubed minus 4x squared plus 6x minus 4. And that is the end of the Unit 2 Lesson 6 video.